Hello there, Mr. Sutton here, bringing you the Pre-Cal Honors 2-6 Extra Practice Number 1 solutions on writing polynomial functions. To find the possible equation of this polynomial, let's first look at the overall sign of the function. So since we're ending down as we move to the right, this is going to be a negative function. So I'm going to write y equals negative, and then we'll figure out the rest of it. Now, moving from left to right, looking at our factors, we're hitting the 0, negative 6. So that means we have a factor of x plus 6, but since we're flattening as we go through there, that's actually a triple root, so I have to write x plus 6 cubed. And then we're flattening as we go through 3 as well over here, so this is going to be x minus 3, also cubed. For the possible equation on this one, let me first look and see where we're ending for the overall sign of the polynomial. Since we're moving up as we move to the right, that means we have a positive polynomial, so I'm going to write y equals, and then there's kind of an invisible plus sign right here that I don't have to write. Looking at my factors now, since I'm touching negative 5 right here, I have a factor of x plus 5, but since we're bouncing there, that's a double root, so that's actually x plus 5 squared. Since I'm going straight through x equals 2 over here, that means I'm going to have a single root, so that's going to be x minus 2 just to the first power. For the possible equation on this one, let's figure out the overall sign of the polynomial. I'm moving up as I go to the right, so that means this is positive overall. So I'll write y equals and then kind of an invisible plus sign in there. For the factors from left to right, we're hitting negative 9 first, so I can write x plus 9 as a factor. Since we're bouncing there, that's a double root, so I actually have to write x plus 9 quantity squared. And then same kind of deal at negative 4. Since we're bouncing there, that's another double root, so I'm going to write x plus 4 squared. And since we're going straight through 5, that's a single root, so that's going to be x minus 5 just to the first power, and we don't have to write the little 1 up there. For the possible equation on this one, let's get the overall sign of the polynomial. Since I'm going down as I move to the right, that means this is negative overall, so I'll write y equals negative something. And then for the something here, I have to get the factors involved. So we start at negative 3, or at least we go through negative 3. That's the first intercept as we go from left to right. That gives me a factor of x minus negative 3, or x plus 3. Since I'm going straight through rather than bouncing or flattening, that's a single root. So this is just going to be x plus 3 to the first power, which I don't have to actually write the first power there. And now for the next 0, we've got 1, so that gives us x minus 1 as a factor. Since I'm flattening through 1, though, that's a triple root, so we're going to write x minus 1 cubed. And then since we're going straight through 5 over here, this is just going to be x minus 5 to the first power. To find the specific equation for this polynomial, let's first get a general equation with a mystery constant a out in front. So I know that this function is going to be positive because we're moving up as we move to the right. So that means I can write y equals positive a, just to start with here. And now let me put in all the factors with x's. So as we go from left to right, our first 0 is negative 4. So I'm going to write x plus 4 as that factor. And it's x plus 4 to the first power since we're crossing through there rather than bouncing or flattening. So that's a single root. So there's the first factor. Next one, we have an x plus 1 for this minus 1. Since we're bouncing, that's a double root, though. So this is going to be x plus 1 squared. And then finally, we have 3 that we're going through, just crossing through. So this is going to be x minus 3 first power. Now I need to find the value of a. To get that, let me plug in the point that they gave me so I can replace x and y with numbers. So for y, we have negative 5 here. And then for x, I'm going to replace all of those with 0 from the x value of that point. So I have a times 0 plus 4. 0 plus 1 squared, and 0 minus 3. So let's see here. We got just 4 times a there. 1 squared is 1, so that doesn't make a difference. We have a negative 3 over here. Negative 3 times the 4a that I already had gives me negative 12a. And then dividing both sides by negative 12, I get a equals positive 5/12. Now I'm going to plug that back into the original that I wrote up here. So that's going to be y equals 5/12 times x plus 4, x plus 1 squared, x minus 3. Before I can get the specific equation for this polynomial, let me write a general equation with an a out in front. because I don't know what the mystery constant is just yet. So for the overall sign of this polynomial, since we're moving up as we go to the far right, this is a positive function, so I'm going to write y equals positive a. And now for the factors with x's in them, we have a negative 3. That's the first 0 that we hit as we move from left to right. So that gives us a factor of x plus 3. Since we're flattening through that, that is a triple root at negative 3. So I have to write x plus 3 quantity cubed. And next, we're crossing through 4 without doing anything else. So that's going to be x minus 4 for the factor. And since we're crossing through, that's a single root, so x minus 4 single power, first power. Now to find the value of a. I'll do that by plugging in the point 0, negative 2, since that is on the graph. They gave that to me. So for y over here, we can write negative 2. And for all the x's, we're going to plug in the 0 that's part of that point. So we have a times 0 plus 3 cubed times 0 minus 4. 3, this is basically 3 in here. 3 cubed is 27 times the negative 4 over here. That's going to be negative 108. So I have negative 108 times a on the right side. Dividing both sides by negative 108 to get a by itself, that gives us positive 2 over 108, which I can reduce to positive 1 over 54. So that's the a value, but we still have to plug that back into the function that we wrote in the beginning. So we write y equals 1/54, x plus 3 cubed, x minus 4. For the specific equation for this polynomial, let's begin by writing just kind of a general polynomial for this with an a out in front to represent kind of the mystery constant that we need to find. So since I'm ending down as I move to the right on this thing, that tells me my overall polynomial must be negative. So I'll start by writing y equals negative a just to represent that. And now for all the x's and factors and whatnot, let's go from left to right here. So our first 0 is negative 2. That gives me a factor of x plus 2. Since we're bouncing there, that's a double root. So that means that I need to have an x plus 2 quantity squared. Next, we're crossing through 2 without doing any bouncing or flattening. So that's a single root at 2. So that's going to be x minus 2 to the first power, which I don't have to write the first power. Same kind of deal at 5. We're crossing straight through there. So that's x minus 5, first power. Next, to find a, let's plug in the point that they gave us, which was 0, negative 6. So I have negative 6 for y. For x, I have 0 getting plugged in. So we have negative a times 0 plus 2 squared, 0 minus 2, and 0 minus 5. Let's see, 2 squared basically is what we're dealing with there, so that's going to be a 4. We've got 4 times a negative 2 over here, that's negative 8, times a negative 5 gives us 40, but we have a negative a times that, so that's negative 40a when all is said and done on that right side. Dividing by negative 40 to get a by itself, we have positive 6 over 40, which I can reduce to positive 3 over 20. So that's my a value. I'm going to plug that back in now to the original thing that I wrote up here. So we can write then y equals negative 3/20 times x plus 2 squared, x minus 2, x minus 5.